Hello friends, today I am going to solve the problem minimum cost to fill given weight in a bag. So the problem is stated we have given a bag of size W kg and we have also given a cost of packets different weights of the orange. In area cost, find the and we need to find the minimum total cost to buy exactly WK oranges. Okay. So the cost of 1 kg orange is present at 0 index, and in general it has given that area of I, that is cost of I, has cost of I plus 1 kg orange. Okay, and cost of I minus 1 means that I plus 1 kg packet of orange is not available. If it is not possible to buy exactly W kg orange, then we need to return minus 1. It may be assumed that there is an infinite supply of all available packet types. Okay, so here is given that we have an infinite supply, and so somehow we can relate this problem with knapsack problem. Okay, so let's this problem is somehow related to knapsack problem or pick non-pick problem. Okay, pick non-pick non-pick problem. Okay, so how we can solve this problem? So let's assume that we have given this cost array with a weight of 5. Okay, so let's find this. So currently I will create a function with two parameters here. One is index that representing here and one represent the weight w. Okay, so let's me write 4 comma 5. So this function will call a pick function, will call two functions. One is for pick and one is for non-pick. So we need to choose we need to return the cost. So as we have given that this the cost at 0 index represent the cost of 1 kg, it represents the cost of 2 kg, and similarly 4 index represent the cost of 5 kg orange. Okay, so I am here at 4 index and I need to pick uh, this one and not this one. Okay, so I can pick this one because my weight is 5 and I can pick a weight of 5. Okay, so what I will do, I will return 100 plus I will call another function. Let me write here. Yeah, I will call another function with the same index. Currently I am 4th because there is an infinite supply of packets of orange. So I will pass the same index and I will reduce the weight because I pick this packet of orange, so my weight becomes 0. Okay, similarly if I don't pick any orange, so what I need to do, I need to reduce the index by 1 because if I am not picking this packet of orange, so what I need to do, I need to do further goes other indexes. So I reduce the index by 1 and I will pass the same weight. Okay, and again this function as the weight is 0, so what we will do, we will return the 0. Okay, this is a edge case that if our current weight is 0, so what we are going to do, we are going to return the zeros. This function is completed. Let's check for this one. The I am currently at third index here, and our weight is 5, and for this we can pick 4 weight of orange. So what I will do, let's let me write here. So the cost of 4 weight package is 50. So I am going to write here 50 plus. Okay, and what I will do, as there is an infinite supply, so I will remain in the third index, and I will slightly reduce my weight because I pick 4 weight of package this one. So my current weight becomes 1 because 5 minus 4 is 1. Okay, but what if we are not picking this fourth weight package? That means the current third index packet. So what we need to do, we need to move further. So I will reduce my index and I will pass the same weight. Okay, yeah, yeah, and this function will call also not pick and pick, not pick and pick. Okay, so let's me again here somehow. Okay, as my current weight is 1 and I am third index, which weight is 4th. Okay, so what I need to do, I can't pick, I can't pick. Okay, so I will call the further for the not pick. Okay, so what I will do, sorry, so I no need to call this because our weight is already 1. So I will call for the not pick. This call goes for the not pick, and I will slightly reduce my index because we are not picking the current one, so we need to return, we need to move further. So here I reduce my index and my weight will remain same because we are not picking anyone. Okay, for this I will call not pick pick. So I am currently at 2 index here, and the cost of 2 index is 4. Let me write here, and the we will call to function. Let me write here. So I will choose this one. Okay, okay, so I choose the 2 index, this one. So I will, as picking up, as there is infinite supply of orange, so I don't change the index and I will reduce the weight. So I pick from the 2 index, so 2 plus 1 3. So I will reduce 5 minus 3, that our weight becomes 2. Okay, and here I we are not picking anyone, so what we need to do, we need to return, we need to move further with the same weight. Okay, and here I will call for the further. our weight is 2 and we are currently at the 2th index, which represent the third weight of the cost. So we can't pick this cost because our weight is slightly less than that one. So what I will do, I will not pick. So I will slightly reduce my index by 1 with same weight 2. Okay, here I have I am currently at this one. So I will pick the cost of become 10 plus. I will call as I am picking up, so I will not change the index and I will reduce the weight. So weight becomes 5 minus index plus 1. So for this the weight becomes 3. Okay, and I will call for the not pick. So if I am calling for the not pick, so I need to reduce the index 0 comma 5. Okay, yeah. So let's further call it. So I am here at one index, so I can pick because its weight is current 2 and I will call for the current one as I am picking up, so I will not reduce the index value and at I 2, so our weight becomes 0 because I pick up this weight of orange which has a weight of 2, so our current weight becomes 0. And if I don't pick this one, so I will reduce my array size, array length, so the index goes 0 and the weight remains same. Okay, for this f1 comma 3 I need to pick. So what I will do, I will return 10 place. I am picking up, so I will done the 1 with 3 minus 2 1. Okay, after reducing this one, I also need to call the not pick problem. So I will reduce my index 0 and will pass weight same weight, that is 3. Okay, and here I am at the index 0 here with a packet of weight 1. So what I will do, I will need to pick 5 kg. Okay, if I need to 5 kg, so how can I pick? This represents the cost of 1 kg. So how can I will return? I will return cost of 0. Let me. So how can I represent? So I will represent cost of 0 into weight. Okay. So it will return. Here the cost is of 1 kg packet is 20. So it will return 100. Okay. And this will also return 60. This will return 40. Okay, and here we need, and this will return 0 because our weight becomes 0. And if our weight is already 0, so we no need to pick anything. So current weight is 0, so we will return 0. Okay, yeah, let's also solve for this. Here I can't pick because I am currently at index 1, which represents the cost of packet of weight 2, but my current packet size is 1. So what I need to do, I need to not pick. So I will go 0th index and I will pass the same weight. At the 0th index, which represents the cost of 1 kg orange. So it will return the 20. Okay. So here the cost is 0. So it will return 10 and it will return 40. And we need to return the minimum cost. So here we will go 10, 40 minimum, that is 10, and here for it is 10, here it will return 20, so it will take 20, and so here becomes 30, and here is 60. Okay, so it will take this function will take the minimum of 30 comma 60, so it will take 30. Okay, and 10 plus 30 represent 40, and here a cost represent the 100. Here let me write 100. So this function will take the minimum of both one. So it will take 40. And here this function value is 10. So 10 plus 4, 14. So this function will return 14. Okay. And this function return 40. And let's say we have not solved this one. And we can further need to reduce it. So apart from this, as we can look that our current weight is already 50. Okay, and if it will return something maximum, so what will happen? The value becomes maximum. Okay, means this value represent greater than 50, and here this function need to choose the minimum of this peak and this not peak. Okay, so what it will do, it will choose the minimum, which is currently 14 here. Okay, and here it is returning 100. So here value is 100 and here is 14. So it need to choose the minimum. So it will choose 14 and give the output as 14. Okay, so let the output, and here is 14. So let's check how we solve this problem by going into the code problem. So let's me remove this one. Okay, let do coding, and let me also reduce this one. So here is the cost size. I have taken the cost array length. Okay, and I am calling a function which taking the parameter index, a weight w, and vector of index cost, and a dp size. Let me firstly remove this, and we need to call this. Okay, so what we need to pick, and we need to not pick. Okay, at the pit currently we are for the interface. Okay, so what I will check first before picking up, I will check if my current cost of index if is not equal to -1, because here is saying if cost of at any index represent -1, it means that package of orange is not available, so we can't pick. So I will check if my current index is not equal to -1, and then my weight is slightly greater than or equal to index plus 1, because each index represents the weight with their index plus 1. Okay, so I need to pick, so I will pick, and the cost of picking is cost of index plus I will further call for the next function. So here I am not reducing the index because there is infinite supply of orange, so index will remain same at the picking time, and I need to reduce the weight. So let me reduce the weight. Yeah, and we will pass the cost, and at the not pick we are not picking anyone, so the cost will remain 0. So let's call the, we need to call the same function. Okay, but in this case we need to reduce the index -1, index by 1, and we no need to reduce the weight because we are not picking anything. So why we need to reduce the weight? So weight will remain same, and at the last we need to return the minimum. Pick comma not pick. Okay, so let's write the edge case. If my weight is already 0, so we no need to do pick non-pick. We will return the cost 0 because there is no cost to pick if we don't have any weight. If weight is 0, so we will return 0, and if our index goes to 0, so what we need to check, we first need to check this one. Okay, if our cost of 0 is not equal to -1, that represents that weight is get the packet of one weight is available. Okay, and if the weight is less than or equal to 1. Okay, so what we need to do, we need to return the cost of 0 into weight. Okay, as we have talked here, and let's do. But what if this is not the case? So we need to return 1 in 9. That represent that we can't pick this one. Okay, we can't pick the orange available at cost, available at index 0. If what if we do, we not do this, so what happen, it will also return, because here we are checking weight is greater than or equal to 1. If weight is 0, so we already call this one, so it is already going to return 0. But if weight is greater than 1, then we are returning this one. So we can assume that if we reach this call, so we already have a weight greater than 1. Okay, yeah. Here I am calling this function, and if I am checking the, if the returning value is 1e9, that is max value, so what we need to return, we need to return -1 as the following stated. If it is not possible to buy Jetly WK orange, then we need to return -1. So here I am doing the same thing, we are returning -1, otherwise we are returning the value. Let's compile and run. Let's check, here is, yeah, Here is a syntax error. Yeah, here we are calling the DP. Let me also delete. Yeah, it is working fine. Let me submit it. It is going to give the time limit is shared. Yeah, for the one last test case, it gives the time limit is shared. So what we can do, it is a recursive function. So we can memorize at the some steps. So let's check. Is there any this sub problem overlapping? So we can check that. I find that there in the this for cost study there is no sub overlapping problem, but eh, for the different test cases there is possible overlapping sub problem. So what we need to do, we need to convert this code into memorization. So we will going to create a dp array with a size of n plus 1 because our index value is going to from n minus 1 to 0. So to store the n minus 1, I need to declare a dp of size n. Yeah, so I need to declare a dp size of n and vector of n and the weight to as the weight goes from 0 to w weight given. So our dp second vector will take w plus 1 is self-held with 1, okay, minus 1. And at the last I am passing dp, and here let me pass dp and also write here dp, here dp, and here dp of index comma w, okay. And here we can check if dp of index w is not equal to minus 1, then we are going to return the dp of index comma w. So this is the function. Let me compile and run. Yeah, it is working fine. Let's submit it. Yeah, so the code submitted successfully, and I have already provided this code here. So if we talk about the time complexity, so what with the time complexity? We are calling two function. Okay, so the call goes to, and for the nth index goes from 0 to n. Okay, and here is an infinite supply of, let's check. Here I have provided today is for this problem of the day solution. You can check it out and use this code, but before using this I would suggest to try first your own, okay. Yeah, so we are talking about the time complexity. So time complexity goes from, we are calling 2.2, and the index value goes from n, and the weight is changing also. So for this I will say that it will this one, But if we are using the memorization technique, so the time complexity reduced to this one. Okay, yeah, thank you for watching. Please like and subscribe my video if you find the solution useful. Yeah, thank you for watching, guys.